Welcome to the video on distance, midpoint, surface area, and volume in 3D. So to find the distance between 2 points in 3D space, if your points are x1, y1, z1, and x2, y2, z2, your distance is going to be the square root of the difference between your x values squared plus the difference between your y values squared plus the difference between your z values squared. So this is kind of like your Pythagorean's theorem. So if you had an x and y value only, and you had points here and here, basically what you're doing is you're finding that distance by taking the difference in y squared and the difference in x squared, and the square root of that will equal your distance. So it's like your right triangle here with the Pythagorean's theorem. So in our example, it says find the distance between 1, 3, 2 and -1, -6, 6. So our distance will equal the square root of x2, -1, minus x1, so -1 squared, plus the difference in our y values. So we'll do -6 minus 3 squared, plus the difference in our z values, 6 minus 2 squared. So we could choose to have either point as our first or second point, as long as you keep it consistent. So our -1, -6, and 6 are first. And that's how it should be because they're all from the same coordinate. So our distance is going to equal the square root of -2 squared plus -9 squared plus 4 squared. So that's the square root of 4 plus 81 plus 16, which is the square root of 101. So your distance equals the square root of 101. Now we have our midpoint. To find the midpoint between 2 points in 3D space, you'll find the average of your x, y, and z values. So you have x1 plus x2 divided by 2, y1 plus y2 divided by 2, and then z1 plus z2 divided by 2. So for this example, it says find the midpoint between 1, 3, 2 and -1, -6, 6. So your midpoint would be 1 plus -1 over 2, comma, 3 plus -6 over 2, comma, 2 plus 6 over 2. So this would be 0 over 2, -3 over 2, and 8 over 2, which simplifies to 0, -3/2, 4. And that's your midpoint. So next we have the volume and surface area of 3D figures. So for your right pyramid, your volume equals 1/3 times the area of your base times your height. And your surface area is 1/2 the perimeter of your base times your slant length plus the area of your base. So right pyramid would be any figure like this with whichever shape it says on the bottom. So you could have a triangle on the bottom, you could have a square on the bottom, or any other shape. Your right cone is basically a pyramid, but your shape is a circle on the bottom. So if there's a circle, it wouldn't be considered a pyramid, it would be considered a cone. So your volume of a cone is 1/3 pi r squared h, and your surface area is pi r times your radius plus your slant height, which can be found by taking the square root of r squared plus h squared. For a sphere, your volume is 4/3 pi r cubed, and your surface area is 4 pi r squared. And then for a hemisphere, so half of a sphere, your volume is half of the volume of a sphere, so it's 2/3 pi r cubed, and your surface area is going to be 3 pi r squared because it's the area of half of the sphere plus the area of this circle here on the bottom. So these are important formulas to remember so that you can use them on the test to find different volumes and surface areas of figures. So here's our first practice question. It says find the midpoint and distance between 2, -1, 6 and 12, 4, -2. So our distance will equal the square root of, so we can use this as our first point this time, and this one as our second. So we'll do 12 minus 2 squared plus 4 minus negative 1, so plus 1 squared, plus negative 2 minus 6 squared. So this equals the square root of 10 squared plus 5 squared plus negative 8 squared, which is the square root of 100 plus 25 plus 64, which equals the square root of 189. 189 is 3 times 63, and 63 is 3 times 21. So our square root of 189 can simplify to 3 square root 21. So our distance equals 3 square root 21. And you probably want to write units because they don't actually give us the units here. So for our midpoint, it's going to be the average of our x values, so 12 plus 2 over 2, the average of our y values, 4 minus 1 over 2, and the average of our z values, negative 2 plus 6 over 2. So that equals 14 over 2, comma, 3 over 2, comma, 4 over 2, which is 7 3/2, 2. So that's your midpoint. Now we have our second practice question, which is also no calculator. It says find the volume and surface area of a right cone with a diameter of 6 centimeters and a height of 4 centimeters. So for the volume of a right cone, we'll have our cone that looks kind of like this. Our diameter is 6 centimeters, which means our radius is 3 centimeters, and our height is 4 centimeters. So volume equals 1/3 pi r squared h. So that's 1/3 pi times 3 squared times 4, which is 1/3 pi times 9 times 4. The 9 and the 1/3 simplify to 3. So 3 times 4 is 12. So we have 12 pi centimeters cubed is our volume. For our surface area, we have pi r times r plus our slant length. So our slant, it makes a right triangle. So to find our hypotenuse here, we'd use Pythagorean's theorem, which we'll learn more about in a later video. And that's going to be 4 squared plus 3 squared equals our slant length squared. So L equals the square root of 4 squared, which is 16, plus 3 squared, which is 9. So the square root of 25, which is 5. So our surface area equals pi times our radius, which is 3, times our radius, which is 3, plus our slant length, which is 5. So it's pi times 3 times 8, which is 24 pi centimeters squared, because this is surface area. Next it says find the volume and surface area of a right square pyramid with a side length of 6 centimeters and a height of 4 centimeters. So you'll have a pyramid kind of like this. And this base here is a square. And our side lengths are 6 centimeters. And our height is 4 centimeters. So our volume will equal 1/3 area of the base times the height. So that's 1/3. The area of our square would be 6 times 6. And we'll multiply that by our height, which is 4. So it's 1/3 times 36 times 4. Our 1/3 and 36 can simplify to 12 over 1. And then we have 12 times 4, which is 48. And that's centimeters cubed. Then for our surface area, it's going to be 1/2 the perimeter of the base times the slant height plus the area of the base. So our slant height will be the same as it was in our previous problem, because we'll have half of our base is 3, our height is 4, and it would be the same equations as the previous problem to find that L equals 5. So it's going to equal 1/2 the perimeter of the base, so that's 6 times 4, because we have 4 sides that are 6 centimeters long, times your slant length, which is 5, plus the area of your base, so 6 times 6. So this equals 1/2 times 24 times 5 plus 36. Half of 24 is 12, so we have 12 times 5, which is 60, plus 36, which is 96 centimeters squared. So there's your volume and your surface area for both of these figures. So in summary, our distance between 2 points is found by taking the square root of the difference between your x values squared plus the difference between your y values squared plus the difference between your z values squared. Your midpoint between 2 points is the average of your x values, comma, the average of your y values, comma, the average of your z values. And your volume and surface area of 3D figures can be found using the formulas here, and those are important formulas that you're going to want to remember. That's all for this video. Thank you for watching.